This ShowMe is about solving equations with variables on both sides. The first time students encounter this kind of problem, they're often intimidated. The important thing to remember throughout the entire problem is that even the numbers you do not know follow the rules. So you can do the same things to the variables in general that you do to the numbers that you know. You can add and subtract them from both sides. You can multiply both sides by them or divide both sides by them with certain constraints. I'm going to talk about some of those strategies here in order to solve some linear equations in one variable. Okay, so I've written out an equation here where there are x's on both sides, and I've also drawn a visual model using rectangles and an attempt at squares. The green rectangles all represent x's. So on the left side you see 6 rectangles. That's for 6x. Then you see the 5 squares on the left side. Those represent 5. The same way on the right side you have the 4 green rectangles representing 4x. And then the 9. Every now and then the counting skills really do come in handy. And then the 9 squares for 9. Okay, the objective here, what we want to end up with, is a statement that says x is something. We want to strip a lot out of this original equation. We had 6x plus 5 equals 4x plus 9. That's a lot of information floating around. At the end, we just want to say x equals something. So we are not concerned about preserving things. We're concerned about stripping away all of the other stuff to find out the important truth, the value of x. First thing you should always ask yourself in this situation is, which side of the equation has more instances of the unknown? In other words, which side has more x's? In this case, the left side has more x's. We're going to put all the x's over there, and we're going to do that by subtracting unknowns from each side so that only that side has any. That means that on the right side, where there are only 4 x's, we're not going to have x's anymore. How do we do that? We simply get rid of all the x's. Now, it's not as simple as all that. When you get rid of a number that was added, such as 4x, what have you really done? Well, if you get rid of a number that's been added, you've subtracted. And we know the rule. Whatever you do to one side of an equation, you must also do to the other side. We just subtracted 4x from the right side. We're going to have to subtract 4x from the left side as well in order to maintain equality. That's an old rule. We're familiar with that. So say goodbye to the x's on the right side altogether, and say goodbye to 4 of the x's on the left side. So our equation has changed too. Looking at our visual model, we don't have x's on the right side anymore. Those are all gone. On the left side, we don't have 6 x's anymore. Now, we have 4. No. Wow. Now we have 2. Just like the model says. Because 6 minus 4 is 2. So now we have an equation, and frankly, I could stop right here. I know that everybody watching this probably knows how to proceed from here. The intimidating part of the problem was that we had x's on both sides. Well, now we don't have x's on both sides. I like to call this setting the dumpster on fire. We've turned the problem into one we already know how to solve. Having said that, though, we need to know how to finish the problem. Well, all the variables are now on the left side. If you look at our goal, x equals, all the variables are indeed on one side. Notice that there isn't anything else visible over there with the x, which means that all the other numbers have to move to the right side, which means we're not supposed to have plus 5 on the left anymore. So let's get rid of it. Let's get rid of those 5 squares. Of course, when you get rid of those 5 squares, you're doing something. You're subtracting 5. Well, if you subtract 5 from one side, you have to subtract 5 from the other side too. So 5 of these squares are going to go away, that's not going to be a 9 anymore. It's going to be 9 minus 5, which is 4. Now we have to divide by 2, because as you can see, we have 2 x's up here on the left in our equation, but we only have 1 x on the left in our answer. So, divide each side into 2 equal groups. Well, the left side divides into 2 equal groups of 1 rectangle, and the right side divides into 2 equal groups of 2 squares. We're not interested in what 2 x's equal. We're only interested in what 1 x is. So, one of those x's can go away, and of course that means one of these groups over here can go away. And the result is that we have a group of 1x equal to a group of 2 squares. In other words, we're dividing each side by 2. So mission accomplished. X is 2. What we need to do now is put this into a process and get into the habit of doing things so that we can acceptably complete homework and repeatedly solve problems and eventually get a really strong understanding of how this process works. So let's repeat that process, this time without the visuals. Which side has more A's? Well, the left side does. It has 9. The right side only has 4. 9 is bigger than 4. So, let's get rid of the A's that are on the right this time. So we'll subtract 4A from the right. And of course, if we do that to one side, we have to do it to the other side. On the left side, 9A minus 4A is 5A. Plus 2 is still there. We didn't touch it. On the right side, 4A minus 4A is gone, but we still have negative 18. Now all the variables are on the left side. That means that all the constants, all the numbers without variables, should be on the right side. Well, what's on the left side that doesn't have a variable with it? I think that would be the plus 2. How do we make a plus 2 go away? And we do the opposite of adding 2, which means we subtract 2. And of course, if we do that to one side, we have to do it to the other side as well. On the left side, then, we just have 5A. And on the right side, we have negative 18 minus 2, which is negative 20. Now, I'm not interested in what 5A's are. I'd like to know what 1A is. Well, that 5 has to go. The 5 is currently involved in a multiplication. How do you unmultiply? You divide. And if you do it to one side, you must do it to the other side. 5 divided by 5 is 1, so I do indeed have 1A. And on the right side, I have negative 20 divided by 5, which is negative 4. This is the base version of how your work should look when you do this kind of problem. We're going to play this game 2 more times. In this problem, we need to figure out which side has more B's. On the left side, I have negative 8 B's, and on the right side, I have 6 B's. And I'm pretty sure that 6 is bigger than negative 8. So, I want to put all the B's this time on the right side. Well, if they're all going to be on the right side, they can't be on the left side. How do I make that negative 8B on the left side go away? Well, right now I'm adding negative 8B. I suppose I could undo that by adding positive 8B. So let's add 8B. Of course, if I add 8B to the left side, I also have to add 8B to the right side. On the left side, then, the negative 8B and 8B will cancel each other out. All we have is 13. On the right side, negative 15 is still there. But now we don't have 6 B's, we have 6 B's plus 8 B's, which is 14 B's. Now that we've established that the variables are going to live on the right side of this equation for the rest of our work, the negative 15, which does not have a variable, needs to be removed from the right side. We can't just remove things, of course. We've got to follow our rules. Right now we're adding negative 15 on the right side. To undo that, we should add a positive 15. And if we're going to add 15 to the right side, we also have to add 15 to the left side. On the left side, 13 and 15 give us 28. On the right side, negative 15 and 15 cancel each other out. We'll have 14b. Finally, we're not interested in what 14b's are. We want to know what b is. So we'll divide both sides by 14. And 28 divided by 14 is 2. And 14b divided by 14 is b. And that gives us our solution. One more example, and we're ready to wrap this up. Well, this problem poses a bit of a challenge. The left side has our p imprisoned in a set of parentheses. And we really cannot use, well, actually the right side does too, we really can't use the methods we've been practicing in these recent examples unless we deal with that. Fortunately, we do have a procedure for dealing with that. Take a moment and think, how could we break these variables out of these sets of parentheses following a rule or procedure that we've already learned? Well, if you remember that we can get rid of these parentheses using the distributive property, give yourself full points. On the left side, we need to take 8 times every number that's inside the parentheses. 8 times 7 is 56. 8 times negative p, remember that's a 1 there. 8 times negative 1p is negative 8p. Negative 8 is still there. Over on the right side, everybody inside those parentheses needs to be multiplied by negative 16. Negative 16 times p is negative 16p, and negative 16 times negative 2 is positive 32. We're almost ready to use what we've learned. On the left side, we still have a bit of an issue. We have 2 constant terms. We really should only have 1. 56 minus 8. We can put those 2 terms together because they have the same combination of variables. They have no variables at all. 56 minus 8 is 48. So we can put that over there instead of both of the numbers. Now we have a problem just like the ones we've been doing. Now we can use our new techniques. You know the first question. Which side has more p's? Well, the left side has negative 8 p's. The right side has negative 16 p's. Despite the visual challenge here, it's true that negative 8 is larger than negative 16 because of the way we order integers. So we should be putting all of our p's on the left side. Well, we don't want p's on the right side anymore. How do I get rid of my negative 16p? Well, do it by adding a positive 16p. But if I do that to one side, I must do it to the other. On the left side, negative 8p plus 16p is positive 8p, and 48 is still there. On the right side, the p's are all gone, and all we have left is 32. Now we need to get rid of that 48 on the left. The left side is now the home of variables and only variables. So, since it's being added, we get rid of it by subtracting. So subtract 48 from each side. You end up with 8p equals negative 16. And by now you should be familiar with the final step. Divide everything by the number that's being multiplied by p. 8p divided by 8 is p, and negative 16 divided by 8 is negative 2. And we have our solution. That one was a little more complicated, but it's certainly fair game. We have learned the distributive property, and it does apply to problems like these. I hope that helps you understand how to attack these problems that look intimidating, but in fact can be governed and solved by the same rules we've already learned for solving equations with variables.